This is motion part 2. We discussed about what is motion, types of motion, and also talked a little about how to describe motion. But like I said, that I gave you a certain idea about the frame of reference or what frame of reference was. Now I really would like to explain it furthermore using some more examples. So let's try to understand frame of reference by some more examples. Okay, so frame of reference, right? Let me think that this is a tree which is obviously at rest. Okay, and this is a car. Again, this is a car. This is different positions of that car. Okay, and there are two people sitting inside, right? Two people sitting inside. Okay, so let's begin. I said that I wanted to talk about frame of reference. I've considered that this is a tree. This and a car was coming. A car was driving on this road. Let me say that this is a road, right? This was a road. On one side of the road there was a tree that was planted there, and this was a car that was moving right ahead on the tree. So this car at some point at this point was quite far from the tree. Okay, but right now at this point B, this car is near to the tree. So how can I say that this car has changed its position? How can I say that? It keeps on moving around the road, right? I will look at the point. I will look at the movement of this car through point of view of this tree. Whenever I want to describe the motion of this car, I will say that at position A, the car is quite far away from the tree, but then it performed some motion and passed right ahead of the tree and went on its way, right? So what I've done is that I've said that this car was at one point this car was quite far, but at another point it kept on getting closer and closer, and then it just went away. So this tree, according to which I'm trying to describe the motion of my car, is basically my frame of reference, right? My frame of reference. I said that uh, a car was coming, a car was coming, and then there was a tree. A car was coming along, it forward to it, and then it moved, and went right past the tree. So what I'm doing is that I'm keep on mentioning that tree. Why I'm doing that? Because I'm trying to mention the motion of this. I'm trying to mention the change in the position of this car with respect to this tree. So any object with respect to which you can define or describe the motion of another object is a frame of reference. Here I'm trying to describe the motion of this car with respect to this tree, that at one point it was near, that another point it went it right past through it. So I know that since this was at rest, obviously it changed its position. It changed its position, that means it performed some kind of motion. Let me think about it, that if in spite of, or if except this tree, there are three people also that are standing right here, or let me say that there are just two people standing right here. See, so these two people will also act as a frame of reference for these two for this car. Okay, but you need to keep in mind that actually motion depends upon the observer who is observing. Motion basically depends upon the person that is observing. For example, for these two people which are sitting in the inside the car, they are at rest while these two people are in motion. So according to them, they are changing their position, so they are performing motion. But if I go and talk to these two people, they are going to say that they are at rest, they are not changing their position, they are not performing any kind of motion. However, since the position of this car is changing, so they and the people that are inside are performing motion. So basically frame of reference is very important, as it can describe, or it can help us to know about the change in position, or help us describe the motion. And also the motion basically depends upon the person that is observing the motion. Okay, so now we've talked about frame of reference. Let's move on ahead. I said that a motion of a particle is described by the position, and that means I need to know when a change in position has occurred, and what are the different things, or what are the some quantities which can help me decide whether some kind of motion has occurred or not, right? See, motion position, Whether a position has changed or not can be helped or can be known by two terms called path length and displacement. So before talking about them, let us try to understand what does a position means. Position is location of an object or point at which the object is located at a particular instant or point of time. That means where my object is located or where my object is placed at some point of time is its position. Okay, why I have introduced time? Because time is a very important constraint when you're talking about motion or when you're talking about changing your position. If I've got a boy right here which was at, let me say, at 5:10 at point at position A, but when it became 5:15 he changed his position and moved right here. So he took some time in changing his position, right? He in changing position he took some time. So that is the reason why we describe this time constraint in describing position as well, because whenever you are going to change your position or whenever you're going whenever you are going to make some movement, you will definitely take some time. So how what can I define from see at 5:10 this A point is the position of this boy, that is the location at which this boy is at time 5:10. However, at 5:15 this B becomes the new position of that boy. So he had changed his position, and in changing his position what he has done, he has performed motion. Okay, so now you know about the position or how it is defined, and you also know about frame of reference. You do not need to worry or complicate this frame of reference a lot. You just need to remember that anything according to which you can describe the motion of another. For example, if I'm sitting on my bed, right? I'm sitting on my bed and my sister is uh, what is she doing? She's walking from one side of the room to the other side of the room. So whenever I need to describe, whenever I need to say and whenever I need to tell that my sister is performing some motion, how can I do it? I will always say it with respect to me. If my mom comes, she's probably going to say that you are performing your motion while you are walking from here to there. Look at your sister, she is at rest and you are performing your motion, right? So her bigger sister or me, that is the person sitting on the bed, is at rest, and for me she is performing motion. Why? Because she is changing her position. Okay, so let's talk something about this path of length and displacement. Let's say what is path length. Path length, as you can say that as the name suggests, this path length is basically length of the path. And what is length of the path? That is total distance covered. What is it? Is total distance covered. Path length is basically total distance covered by an object from initial position to final position. If from initial position to final position, the distance, total distance covered. For example, if I'm moving from this A point to B point to, I've moved like this. So what is going to be my path length? My path length is going to be AB plus BC, because it is the length of the path that I have traveled. So path length is total distance covered by an object. Okay. Now uh, let's try to think about displacement. What is displacement? See, path length is the total distance covered by an object from initial to final position. It is the total distance covered by an object from initial to final position, whereas displacement is the shortest distance. It is the shortest distance between initial and final point. That is, if you between your initial and final point, the shortest distance is going to be described as displacement. Let's try to understand it with the help of an example. Let's say there is a person, he moved 4 kilometers from A point to B point, and then he moved 3 kilometers from B point to C. So what is his path length going to be? Path length can also be termed as distance. Basically, path length and distance means the same thing. You can either use the term distance or path length. So my path length is going to be what? AB plus BC, right? It's gonna be 7 kilometer, right? But if I, so my path length or my distance is the total distance covered, that is the 7 kilometer, but I want my displacement. So displacement is going to be this, from this initial point to this final point, my shortest distance. See, so my shortest distance is definitely going to be this if I move right, है ना? So AC is my displacement or my shortest distance between my initial and final point. So you know now what is displacement, is the shortest distance between initial and final point. And how, and I need to know what my displacement AC is going to be. I can use right here Pythagoras theorem and probably find the value. So according to Pythagoras theorems, hypotenuse square equals to perpendicular square plus base square, right? My perpendicular is 4, so I'm going to use 4 square plus 3 square. So 16 plus 9, right? And it is going to be 25. And now my hypotenuse square is equal to 25. So this square is going to become root when I take it on the other side of the equal to, and I will get my hypotenuse is equals to now 5, right? So AC, my displacement is basically 5 kilometer. So through this you've got your displacement. So in this way you can calculate your displacement. Now I've talked about path length, I've talked about displacement. You've got a certain kind of idea about what both of these things are. Do remember that path length and displacement are two different things. They have certain difference between them. Okay, see, path length basically depends upon the path. It for path length or for distance, whole of the path matters, but for displacement only initial and final position matters. It only depends upon the initial and the final position. Okay, now if let's say that you want your path length, your displacement to be equal, is there any case or any condition through which you can make your path length and displacement to be equal? Is there a way? Is there any possible way? Let's try to know about it, whether I can find that or not. There is a way. Let's say that there was a straight road and there was a bus. That bus moved from terminus A to terminus B and covered 150 kilometer, right? It moved along a straight line and it actually moved from terminus A to terminus B and covered a distance of about 150 kilometer. So what is my path length going to be? AB, right? And what is my displacement going to be? That is my shortest distance, again AB. So what I've got basically is my path length has become my equal to displacement. Whenever an object basically travels or covers or travels along the shortest path, then in that case his path length can be equal to his displacement. That is, when can path length become equals to displacement? When your object travels the shortest distance. Whenever your object travels the shortest distance, then your displacement can become equal to path length, because this is the shortest distance between point A and point B as well, and my path length has in this case become equal to displacement when this bus traveled the shortest path. Okay, if there is a condition that can make your path length to be equal to displacement, then there should be some condition that can make your displacement zero. So this is a very interesting fact, that even if you're there, you have got some value of path length, that even if you have covered some distance, your displacement can basically be equal to zero. When does that happen? Let's try to see. Now let's consider the same example. We know that our bus traveled from point A to point B and covered what, 150 kilometer. After reaching point B, it made a U-turn and came back to point A. So again covered 150 kilometer. In this case, if I want to know about my distance covered, it's going to be 150 plus 150, right? 300 kilometer. But what is the value of displacement going to be? I already said that displacement depends upon the initial and the final position, and in this case my initial position was A, and when it made a U-turn, then this B actually which used to be its final position changed, and then its final position changed to A as well, right? So in this example that I've talked about, my initial position is also A and my final position is also A. How this happened? It was that it did move to B. It did covered till B, but then at point B it didn't stop and made a U-turn and came back to A. So his initial and final position became same. And when his initial and final position becomes, when any object's initial and final position becomes same, then displacement of that object becomes 0. So even though I've covered some distance, my displacement is 0. See, firstly, how does this happen? In the beginning, when it is going from A to B, it is covering this, in this it is moving toward this direction, right? But when he came back from B to C, he made a U-turn and again traveled from B to C. Now he's covering in this direction. Can you see opposite signs? Can you see the change in direction? See, in both of the cases he's traveling in basically opposite directions. So if I take 150-kilometer distance here, because of the change in the direction, or oppose in the direction, this is going to be become minus 150. Why? Minus sign indicates that there is some change in direction. So when I try to find out my displacement, it is going to be 150 minus 150, right? Then what is going to happen? 0, because he covered 150 in some positive direction, but then he came back and he covered same value, he covered the same distance but actually in opposite direction. So both of them are going to cancel each other out and you will get a value that is equal to 0. So this is how your displacement turns to 0. So the basic thing, or the main things to remember right here are, if your initial and final position are same, your displacement is going to be 0.